So, as we said, in the permissioned blockchain, it also known as your private blockchain. As we says that it is belongs to a group of organizations, or we can say the group of participants or individuals, that has decided to share the ledgers, and they are peer to peer connected in the network. So before they are going to join into the network, they must follow some of the predefined rules, so that if those rules or agreements are done, then they can actively participate in the network. So that we call the private blockchain, or the what you call the permissioned model in that case. So what really we need in that, in permissioned model, permission ledger, as we are saying that they can share this ledger from one node to another node. So how they are going to share this? We call this is a permissioned ledger. We say this. So what happens in this permission ledger? It is just like blockchain, but where the participants of your network are known. As said, they must follow the some authorization process. So they must known and already trusted. So the permission ledger do not need to use a distributed consensus algorithm, because in this short network, everyone known to each other. Okay? So this permission models generally happens in a organization, within the organization, or within a known society itself. But thing is, when everyone known to each other, they can share their ledger. Okay, so whatever the information is there in the network, blockchain network, they can share to each other. So there is no need of any distributed consensus mechanism. But instead of that, they require some kind of agreement protocol. So that protocols, we say it as they must follow some contracts, or we call that as your smart contracts. So this smart contract, they must follow the agreement protocol or smart contract protocol in that case. So by instead they use this agreement protocol to maintain a shared version of your truth about the state of the records on the blockchain. So there is also no requirement for permissioned blockchain to be private, as it can be a public blockchain, but with a regular access control, it will be. So that is the main one. So who will maintain this smart contract then? So this smart contract will be given by some other additional entity. Okay, because as we are saying that it is a closed group and known each other, but we don't know at what time their behavior will be changed. Correct? So that's why we say that the blockchain architecture, where the users are authenticated in prayers. So that is a membership service provider that helps for this authentication for the users to participate in the network. So this helps to obtain the chain membership in the network. So that we call the MSP. Somebody has to authenticate it. So then in this permission model, as we are saying, they are the users known to each other. But however, users may not trust each other, because in our in a closed group they can know to each other, but it doesn't matter that if we don't have more interaction, suppose. So then how can we trust that in the closed group they are the trustworthy? So they trust each other. So security and consensus are still required, because some may be behave that they may do some denial of service activity attacks. So it requires some kind of consensus. So that is what we call the smart contracts are required. Some protocols are required in that, right? So this the permission, the ledger, we can say that the concept of this permissioned ledger in the permissioned model, it is a distributed ledger, is fundamentally different to a public blockchain, but the key idea behind this permissioned ledger part uh, is that they are the permissioned as opposed to an open public blockchain. So there is the what you call the distributed ledger transactions that do not perform any mining, as all the participants are already the vetted and known to the network. So there is no requirement for mining to secure the network in this the permissioned model, because if it is open network, then who are coming inside, who are going outside is doubtful. So that in that case, somebody has to take some responsibility for transaction validation, and then doing the block, preparing the block and add it to the network. But in this one, in permission network, or we call the private network or your permission model, everyone knows to every other, so there is no need to do any mining process. So that will reduce the cost of the mining process, or doing the difficulty of that. So there is also no concept of any digital currency and private permissioned distributed ledger, because the aim of the permissioned blockchain is different from a public blockchain, like from your permissionless blockchain. So in a public blockchain, the access is open to everyone and requires some form of incentives and network that effect in order to grow. So on the contrary, in this permissioned distributed ledger transactions, there are no such requirements. So it is possible to build the permissioned distributed ledger transactions using some private consortium settings. So especially to work within the existing the financial system, the key benefit of distributed ledger system is that they are much faster, governable, and the possible interoperable within the existing financial system. So, but it still requires some kind of security issues. So, how that is going to be achieved means you must run the blockchain among known and the identifiable participants. So, how it is possible then to run this one? So we just consider some, the permission model use case so that you can understand. Particularly, these permission models are interested for the business applications generally. So they must execute the some contracts among the closed set of your participants. So those contracts we call the executable contracts, or we call them as your smart contracts also. So let us take the example for the provenance tracking of your assets in a supply chain method. As we are saying that there is a closed group of let us take an example of your postal department. Suppose somebody is sending a post from one country to suppose another country. So the postal service in one country is different from postal service in another country. So let us assume that to maintain this, the ledgers at a centralized one. Suppose within this country, if I want to post, then I'll approach to the postal department. They will receive whatever post I want to do, and they will give us one tracking number. So we can try to track our post that where it is reached. So by just going to their central server and just clicking that it started from San Antonio at so and so time and reached to Houston at so and so time, and from Houston it started for delivering. So that will be maintained. But suppose in that case we can track every time where our post is there, because that is maintained by the UPS service center here. Suppose if I want to post that some kind of any parcel from US to some X country, suppose. So that X country may have their own postal service. So here the UPS system, they can maintain the the database, the central database, and that's why we are tracking that it is moved from San Antonio to Houston, Houston to some other place. But when it reached to the border of our country, then from that border it is going to hand over to another agency there, another postal service. So their rules and regulation is different. So they maintain their own database, right? They own database, that is centralized database. Then how do we track when our country, UPS service hand over that post to the other country? It's difficult, right? Because their database is not access to us. So then what happens? There should be an agreement between our country UPS system and their postal service. So the way our country maintains the postal database, X country also maintains their database. So our country, the agent should access their database for tracking, and their country agent should access our database if the post comes from their side also. So then, how can these two countries or how can these two agents can trust each other? They know each other, but whatever transactions are updated in our database by them or their database by us, whether it will be trustable or not, there is a question mark. So in that case, if it requires a central database for such kind of thing, then a third party is required, like purchase a cloud. So then, when going and updating the database in the cloud, so the tracking system which is happening in X country, those tracking information should be updated in the cloud, and in our database, whatever tracking system was happened, that should be updated. So both the tracking should be maintained in one database by third party, and then that will be what you call shared to with our agent as well as their agent, so that it can be synchronized. So in this process, what is happening, if you say that some transactions are happening in X country, some transactions are happening in our country, so both are sending to some other country, they are executing those transactions, and the synchronized transactions are sharing with us. So this is represented or collaborated with we call the state machine. So in our state machine system, when you talk about the state machine, in this case study, suppose there is a supplier in our system, suppose, which can provide the vegetables, suppose. So this supplier will have the contract with a distributor. Okay, supplier will have a contract with the distributor. So every time the log should be maintained, so that this asset belongs to this supplier. Okay, so then when this is so in that log, the name of this supplier should be there, and the asset which belongs to this supplier should be there. And when it is received by the distributor, suppose here, so distributor will collect these kind of what you call vegetables from different suppliers and trying to group together and try to distribute it, right? So there also it should maintain in log that some kilos of tomatoes, suppose, belongs to David, some kilos of tomatoes belongs to, suppose, Nathan. Then if they are together packed, then it should be maintained in the log that if 1 kilo belongs to the David, 1 kilo belongs to Nathan, and then that will goes to the next one. So that it goes to the from distributor it goes to the vendor, and from vendor it goes to your marketing place. So everywhere the transactions are updated, and it should be maintained that whose asset it is. So to do that, as we said, the postal example also, it is known to everyone. All the users are known, but sometimes during this transaction somebody may say that no, this is not, this kilo is not belongs to David. So for that it requires a executable contracts over the closed network, called the executable contracts over the closed network. So that we say that the smart contracts, the executable contracts, we say it is the smart contracts. So that is what it called the smart contract means. This is actually a computer program. These contracts will be run by the computers. It is a computer programming contract. So this is not a new concept, but with the advent of blockchain, interest in this concept has revived, and this is now an active area of research in the blockchain space. So, due to the cost saving benefits that smart contracts can bring to the financial services industry by reducing the cost of transactions and simplifying complex contracts. So, the rigorous research is being carried out by various financial industries and the academic institutions in order to formalize and make the implementation of smart contract easy and practical, that is, as soon as possible part. But what is the basic definition, or how this smart contract defines that, or describes basically, is the smart contract is the computerized transaction protocol that executes the terms of some contract. So the general objectives are to satisfy some common contractual conditions, such as like payments, or the confidentiality, or even some enforcement. And either this smart contract should the minimize the exceptions, both the malicious and the accidental, and minimize the needs for the trusted intermediaries, or the related economic goals, that including the lower fraud loss, or the arbitrations and enforcement cost. So basically, it try to defines. There are a lot of definitions are given, but the smart contract should have certain properties. So so that is what saying that a smart contract is self-executing contract in which the terms of your agreements between the buyer and seller is directly written into the lines. So in that it should have the certain properties that we can say the automatically executable. These contracts should be automatically executable, and it must have the enforceable, and third property, it should have the semantically sound, and secure and unstoppable. It must have the secure and unstoppable. So these properties should be there for this smart contract. So in this, the agreement on the smart contract execution, as we says that it store the contract on the blockchain, and once an event is triggered, uh, uh, then it execute that code locally on each pair, as we said that when it is hand over to the X country post. Suppose our parcel is hand over to X country post. then in their database, whatever the contract is there, I mean the smart contract is there, when it is executed there, it must be executed locally, and then it will update into the general transaction part. So it generates that transaction as the output of the contract execution, that, and then the peers of your blockchain network, they must validate this transaction, and the output is committed in this blockchain that may trigger to the next event to execute this code further. So for that it requires some sort of uh, the part that when to execute the code locally and how to execute that code locally on each page. So for that it requires some kind of, so do we really need to execute that code on each peer or not, is comes in the question mark in the peers, I mean the in permission network or closed network. So when does each peer execute this code? So for this it requires this smart contract agreement as a start, state machine replication as said. So what happens in this, the smart contract agreement as your state machine replication means it executes contracts at a subset of nodes. Subset of nodes means like the contracts execute by our UPS postal service, as well as the another contract executes in X country. Okay, that is subset of nodes, and ensures that the same state is propagated to all the nodes. So when the subset of nodes executes node, it must be synchronized by some node, and then that will be what you call the distribute among all the nodes in the network. So what happens here? The majority of the peers in the network should agree on that state. So for that it requires the validation as said. So for validation it generates the proof that a peer has agreed on the state of your execution. So how this proof will be taken then? How will generate this proof? To generate this proof, it follows the state machine replication. So in this state machine replication, it represents the smart contract as a state machine. As we said, smart contract is a computer programmable, right? So remember, any deterministically executable code can be represented as a state machine. So how do we define a state machine? We say that in states, the state in the state machine, the initial state will be modified by some transaction to reach to the next state, and finally all the transactions are verified, then it will reach to your final state. So there will be a starting state, there will be a final state, there will be some intermediate states, and for every tracking, for every agreement, okay, there will be whether it goes to the next state or it will come to the same state, that will be done. So in this case, if you say S1, S2, S3 are three different states, in S1 state, which is your starting state, says that while the more goods equal to 1, then delivery that goods is the first state. So this is a smart contract code, or the template which is used. And the second state, that means what? It is going to the same state that deliver more goods. When it reach to your second state, if all orders completed, when all orders completed is equal to 0, then go to means when the more goods are equal to 1 means collected the goods from you, from X, from Z, and all goods are ready, then deliver it to the distributor. So when it delivered to the distributor will try to do for the marketing, right? When do the marketing means if all the orders are completed, okay, by your the distributor to your the vendor, then go to your state one and say that okay, again try to collect the goods, okay. And if else, if all the orders are not completed, then you go to your state 3 and write the print that the goods transfer is complete, but orders are not complete. So when this is all orders are complete, then you go and say that all goods are transferred is completed. So every time this will be executed. Every time this will be executed because this is smart contract code. So every stakeholder in the network or every peer in the network, they try to execute this code, and it will be automatically execute. As soon as the orders complete, it automatically goes to your state 2. As soon as all the orders complete, it must automatically go to your state 3. So that is your state replica. So let us take this state machine replica with an example. So this state machine means all the servers in this network, they are having the state machine replication. So in state machine replication, as we say that they maintain all the valid blocks. That. So this replica, the state machine on multiple independent servers, server 1 or server 2 or server 3, and they all follow this smart contract. So they all follow this smart contract. So in that smart contract, what is written? In S1 state, it says that means while more goods equal to 1, deliver these goods to the next state. Okay, and if all order completes equal to your 0, then go to your S1 state, or else it is going to your S3 state and giving the print that the goods transfer completes. So the same thing maintained, that state replica machine or smart contract will be there with every server. So as soon as, suppose in transaction 1, I have delivered the 100 kgs of potatoes, then that state machine delivered means what? Your first state 1 is completed, right? Delivered means as per the smart contract. Okay, delivered the goods. So when it is delivered, when someone is delivered, okay, then that transaction will be there with one server. That is one set of node. Then at another point, at another server, I have delivered 50 kgs of tomatoes. So that is also maintained separately, and there this smart contract executes automatically. So there are subset of nodes, they can execute the smart contracts. So after that, what happens? These once these smart contracts are executed, that the goods are delivered, then in the next stage there must require some consensus, that is the agreement on the ordering of this transaction. So what consensus, whether T1 should be executed first or T2 should be executed first. So ordering is required. So it may execute in either way, but that must be shared among all the nodes. So for that, they must share this the information that this server is having transaction 1 and saying that the 100 kgs are delivered. This server having a transaction saying that 50 kgs are delivered. Okay, the 50 kgs are delivered, but it must be shared to others. So first these transactions are executed individually, and after that they must be shared each other, so that everyone is having the transaction, that every server is having the transaction that okay, the first transaction is 100 kgs, second transaction is 50 kgs, similarly here also. And all these smart contracts for your transaction 1 and transaction 2, the smart contract should be executed and they must be synchronized. So first, in order to execute that, so the independently every servers then try to execute that smart contract independently, that the goods are delivered, that what is the 100 kgs goods are delivered. Okay, then they will go and try to go to the next state, that all 100 kgs of your transaction 1 is executed, so go to the next state. In the next state, going and check whether all the orders are executed or not. So here T2 is also there. So T2 transaction should also be there. More orders are there means yes, more orders are there. That is T2 is still there. So then go back to your S1 state and try to execute your T1. So execution of T1 completes, but T2 is still required to execute. So starts executing the next transaction, that is T2. So that is also executed by every individual state machines here. And once they start executing 2 and once T2 is also completed, then you says that at S1 in that smart contract, all the orders are completed and the goods are delivered and they are completed. So then the independently executed these transactions will be shared for synchronization purpose. They will be shared and finally that will inform to the marketing side that all the goods are delivered and the all the transactions are completed, the smart contracts execution is completed. In that they maintain that T1 delivered 100 kgs and T2 delivered your 50 kgs of transaction, and this information will be maintained in the common log. And further, sometimes in this case in state machine replication, why do you need the consensus means your one server is says that all the transactions are completed or all goods are delivered, and second server is also says all transactions, I mean the all goods are delivered, but the third side says that no, the all the transactions are all the goods are delivered and transactions are executed, means the transfer of those orders are completed. So there is some mismatching is there. To overcome from this one, it takes majority of people. So majority voting will be taken, and majority voting will agree on your S1 that the goods are delivered. So then that particular information will be given to this. So in that case, what will happen? The marketing side, okay, in the market side, they can identify who is giving the wrong information. So what will happen to this client? They'll try to this though this client is known, but doing some the malicious activity, so trying to remove that client from the network because doing some the misbehaving activities in the network. So this is what the state machine replication used in permission model. So in this permission blockchain and your state machine replication, there is a natural reason to use the state machine replication that is based on consensus over the permission blockchain. But the network is closed, so the nodes know each other. So the other replication is possible among the known nodes in this permission blockchain. So avoiding the overhead of your mining, they do not need to spend anything like power, time, or spending some kind of Bitcoin in the proof of deposit, other than just message passing from one server to your another server or one peer to another peer. So, however, some consensus are still required because the machines can be faulty or behave maliciously, as we said. Two of the machines are saying that yeah, the goods are delivered and all the transfers are completed, but one machine is saying that the goods are all the transactions are completed as per this what you call the smart contract. So this, as you'd say, the two machines or two peers are saying that more all the goods are delivered and all orders are complete, but the third one is saying simply printing that goods transfer is complete simply without doing this execution. So there it is giving some kind of faulty. So these faulty nodes are there. So how to avoid them means we need a bit of your redesigning of this permission blockchain or permission model. So how do we redesign? For that, we required some the crypto is the savior for that, to find out who is doing the misbehavior in that particular network. So when crypto requires to introduce crypto plus your distributed consensus, which we use like proof of work or proof of stake or proof of your burn, so that gives the consensus for permissioned blockchain too. So with this, it is clear that the classical distributed consensus algorithms, such as your Paxos, the Raft or Byzantine agreements, are based on this state machine replica to avoid these kind of the misbehaving nodes, is to identify them from the network and taking out from the network. So these are the classical distributed consensus algorithm which are used in the permissioned blockchain as you are based on this state machine replication. So we will see these Paxos, Raftoid, Byzantine agreements, in detail how they works in the part. But I'd like to stop this session here, and we'll. If you have any questions,